everybody, I hope you're doing marvellously well. We're here at Keidenkirchen near Nettetal to hang out with Elysia. Now, Elysia, I'm sure you know, makes some of the finest audio products. The Alpha compressor, for instance, which I think came out about 2006, 2007, is becoming, if not already, a standard in most mastering engineer studios. And of course, the Empressor is a masterful, the Expressor, all these incredible pieces of equipment they make, all designed by Ruben, who designed the transient designer SPL. So I'm very excited to be here. The thing about Elysia that I think many of us admire, beyond the fact that the audio is superb, is the fact that they make everything in-house. So that includes all of the box itself, all of the controls, the knobs, you name it, are all manufactured here. So, without further ado, let's go and see how they make these beautiful products. Walk this way. And just a quick sideline. Elysia is from Elysian Fields. Look it up. It's a pretty awesome piece of history. Ruben, how the devil are you?
Hello, Warren. Nice to see you.
Good to see you too.
Welcome here at Elysia.
This is a rather gorgeous place. I love the facilities. I love how much grass and trees and everything you've got.
Yeah.
Do you go out and play sports?
Yeah, we do golf here.
How long have you been here?
Since 10 years now.
10 years?
Yeah, since 2014.
Amazing, amazing.
Yeah.
You made a really good effort to oh, look at this. Look at that.
Yeah.
That's really cool. No, but what a great entrance lobby.
Yeah, I mean, fortunately, this was like this. So when we bought this building, all this interior, the walls and the construction was like this. So we don't have to do it and rebuild it. So it was some luck we have.
Great. Well, this is your place.
Yeah.
I'm at your mercy. What would you like to do? What would you
Yeah,
like to
I like
us?
to. So first of all, this is a place where we do everything here. That means development, production, sales, then distribution of everything. And so it's really, and we do a lot of stuff ourselves. So the manufacturing process is really depth. And so yeah, hopefully you have a lot of fun viewing this because I think you will see some very impressive stuff here.
Okay, good.
So let's start.
So where would you like to start from?
So we start in this direction here. What we see here, the first prototype of the Alpha compressor.
Wow.
It looks, really not like the original one. So, but from the function and the controls and features, it was pretty much what the end of the day was. And all the PCBs was hand soldered, and with this I went into studios and give rehearsals and listening tests, and then we started to construct the other stuff, the real stuff.
Well, it's great. Your first compressor, and you call it the Alpha.
Yeah. Yeah, I think it's the first, and I think the Alpha is really a very special device, and up to now, it's now 18 years ago when I developed this, and it's, I think, some kind of a standard in compression and mastering.
Absolutely. Beautiful, beautiful. Where to next?
Yeah, so I'm your guide, so follow me.
Great.
Yeah, here's our Class A lounge, our mastering grade room. Perfectly acoustic 3. This is Stefan Kolzmann.
All right, Stefan, good to see you.
And
good to see you too.
He's helping us in support and customer relationship, and also the product specialist, and also now mastering the human beat pack here in our studio that we have recorded in February in this year, and he's doing a pretty good job here, I have to say, and.
With Moses Schneider,
so he was also in the move with Moses and was observing everything there.
Yeah, we did it again.
Yeah, exactly.
Now it's coming volume 2.
Yeah. Okay, great. We'll put a link underneath to that. I love Moses' stuff. It's absolutely superb. Yeah.
Yeah, and here's over the real Alpha. I mean, over there was the prototype, and this is now the real one with all the beauty and the functions. And I would always say the Alpha is not only a compressor. For me, it's more a mastering toolbox because it's way more inside rather than a, let's say, classical linked stereo compressor. So we have MS option here. You can run mid and side separately. There's a one-band EQ, a tilt EQ. You can little adjustments in your frequency band. We have a sidechain filter where you can blend from low pass to high pass with a frequency control. We can do parallel compression with the onboard mix, makeup gain, and as well a soft clipper at the output stage. So when I developed this, in that time, it was 2005, in the mastering, the people tend to overload the AD converters like hell, and it sounds horrible. And I thought, okay, let's put something more gentle and sweet in this, and this is a soft clipper. And that's the magic and the beauty of the Alpha, that there is an onboard limiter. So when people get a huge amount of loudness, it's not only because of the compression itself, it's because they're using the soft clipper and pushing it. And then you get rid of this transients and have some more dBs of loudness. Yeah, and this was really the start of Elysia, where we came out in 2006, and yeah, and this was, and follow up other products like the Music and the Empressor, and that's our top mastering range here, and also used in many top studios.
The soft clipper is absolutely fantastic. And you're right, nothing worse than hearing digital clipping.
Yeah,
in a converter.
Yeah. And this combination is so strong, so even when I do some mastering, I only use these guys here, and it's enough. It's really amazing.
Wonderful.
Yeah, and over here we have the, let's say, the other range. And in 2010, we came up with the Expressor, so some kind of a reduced version of the Alpha. It's also a soft knee compressor, RMS-based, so you can use it really for everything. And that we came up first with the 500 series, and then the 19-inch version, and then we follow up with the Expressor, the envelope character. So the envelope is a transient shaper. So I don't know, the people know I've invented the transient designer back then in the end of the 90s for SBL. So, and this was then the next generation of transient shapers, because it's some kind of a multi-band system. So you can split the attack and sustain with different frequencies. Character is a more kind of a distortion overdrive device from also mastering grade. This is stereo EQ. Yeah, and we have from all these 4 devices, we have 500 modules, and then we create a few years ago a new chassis, and the name is Cube. So there is in the 500 series and so it's portable. And you see, like here, if you don't have all this 19-inch space, you can place it here, or it's portable if you want to go to another studio.
Amazing. What speakers are you using in here, just out of interest?
Yeah, these are the original Klein & Hummel O300.
Neumann, yeah.
So it's a similar box, but these are the original from Klein & Hummel. Yeah.
Well, thanks for showing us around here. Where to next?
I'd like to show you the mechanical manufacturing, because this is where I really stand out, I have to say. I'm very special that we manufacture so many parts ourselves. I think it's very unusual, and so we have entered. This room is also special here, because not only a floor, we use it for storage in here, but also, you hear it clapping.
Yeah,
and I will say later, because this is also a reverb chamber that we use for our studio, but the studio came later. First, we see the manufacturing of the mechanical parts, so follow me.
And you've got a Lego man there.
Yeah, next Lego man here.
Wow, this is very, you know, when I look at your products, I sort of feel like they're very state-of-the-art and very clean and very precise. And then we walk in here and
yeah, it is.
This is exactly what I would expect it to be.
Here is a showcase what we do here. So all the parts are manufactured here. So starting from all the front panels, from these rings here, the knobs, and all the other like music and presses, the front panels in between, and from the Alpha compressor. So it's not everything, but you get an idea. And in the past, we have having another company doing this for us, but with the blue color coding, it was a problem because the color was too much difference in there from one chart to the other. So, and then when we thought, okay, let's do it our own, we ordered panels in blue which have the same color, and I'll show you that later.
So you now cut it out of a single panel rather than coating individual pieces. Smart.
And over here we have something which is the first time, but it's really impressive. All the mechanical parts in the Alpha compressor. Normally the people look from the outside, but it's now also the insides.
Absolutely gorgeous.
And we do all this stuff ourselves here. For instance, this is looking weird, but...
Yeah, what is it?
Yeah, with this, we name it a heating system. So the VCA in the Alpha compressor is very sensitive to temperatures. So what we do, we put in here the transistors, and here's a larger transistor that heated that up. on that everything is constant. And then this comes on top that this heating is not bleeding in everywhere. So it's really in here. So we name it T16 heater. So we see it later in the electronic production, but it is something that we develop on our own here.
Now the VCA being very sensitive to heat,
Yeah.
how does that affect it negatively? So if it gets too hot, does it?
No, the parameters are drifting. That's the problem. So let's say the gain is changing. That's the reason why we have it on constant temperature here. Yeah.
I see. So so it basically means that if you're setting it to 3:1, as long as it's at a constant temperature, it will actually give you that result.
Exactly.
Okay, I see.
Yeah, and then this part is special. This is the control for the alpha compressor, and there are two parts. This aluminum ring and the inside, so that we get this blue lightning. From the back, we have an LED in blue. When we manufacture this, we don't have the machines for this, obviously. But when we get these parts, they are not finished because most of the machines could only do one side. So when we got this side was not finished. Okay, how can we solve this? And for that reason, we bought an old machine over there. So we got it like this. So this part was not finished. So this curve here was missing. So it looks a little bit like this here. Yeah.
So, I see. So this is flat.
Because the other machine could only manufacture completely from here to here, but not the end.
Oh, well.
Yeah, so that's the reason why we bought this machine. Frank created some special tools for this. So over here, come on, Frank.
Yes.
I'd like to introduce him.
Hello, Warren.
Yeah.
Hey, Frank.
So this is a long-term friend of mine, and when we were younger, as a teenager, we do creative stuff together. So we built lighting system for our band, for instance. And when he worked in a company that produces machines for automotive, big machines. So he was very into this production, and he helped us a lot in how to produce the alpha compressor. Because we go to designers, and the designers create the front panel. Everything was looking nice, but there was no way how to manufacture. And he was able to convert this into manufacturable parts like this here. So, and then he came up with these special steels here, with foam steels. This came over here and makes the final surface.
I can show you.
Yeah.
Show us one.
Yeah, come on.
Make one for us, Frank.
Yeah. So here you can see how it looks like.
And now it's ready.
Yeah.
That's great.
And that's how I made a lot of these. I mean, the surface is not perfect. Normally, there's some cooling fluid in between. But this is how I made, hundreds of these here. And this stands in their parents' garage. Yeah, really. In the summer, it was totally hot. In the winter, it was cold. But then, as you can see here, normally when you start this machine here and put it in, and start the machine and stop, you have to wait. And then you can open this again. So when you do hundreds of these, it's really time consuming. So then we come up with the idea to put a brake inside. So this is over here. It's looking like a brake from a bicycle. So when I started, it's open, and when I stopped, it's closing. Yeah, and to make that happen, I completely programmed this so that we can create some sequences, starting motor, open this up, and we have also, I think here it's, so there's a stepper motor that we also then embedded to make what he did now manually, did with a stepper motor, to have some kind of automatic process. But it turned out that we were so fast, let's say in 10 seconds, you make this movement here, and then change the part, the next one, all the time.
And this machine is over 60 years old.
Yeah.
Wow.
And also,
In the past, it looks like this.
yeah, no, the original color here.
Original color
Yeah.
from 1960.
Let's show some other stuff. So this is a saw where we can cut things like this here. Let's see. Yeah, like this here. This all this stuff that's in the alpha compressor. So it comes in this length here, and then we cut it into smaller pieces here. It's very handy, and even Frank created this construction here that it holds all these parts and it won't fall down. the buttons for the alpha compressor. That's what you see on the front panel.
That's a basic material.
Yeah, that's what we made out of it.
I love this detail, it's incredible.
Yeah, and here we have the panels, what I was talking about, for the 500 series, for the 19-inch stuff. And this is a protecting foil here, so down here is now the real surface.
I see.
And normally these panels are used for surfaces at large buildings. So every time we order these panels, they have the same color, because this was previously a real problem that the color was totally different.
Yep.
But this is way too large to mill on the machine, so we have these panels here. So this we cut it with this saw here into this size here. That's now fitting perfectly into the machine. And then you saw 4 holes in here, and I'll show you why we do this. So here look alike when we, I think it's espresso or what is?
It's X-filter.
X-filter. So here's also, you see the holes there, because this process is that you have to mill both sides, front and back side. And the problem is when you flip this, that you have the same position. Otherwise, there's an offset between front and rear.
I understand.
And so he came up with the idea, and having this referencing system, put it down, and if you flipped it, it's exactly in the same position. And the next thing is that we have, because it needs to be fixed now, even if it is milled, it is fixed because it's held by vacuum. And we have special holding system with rubber, what it is?
Yes, it's silicone.
It's silicone, yeah, sorry. Silicone. Can you show me another of this?
Yes.
Yeah. So this is silicone for the 500 series. And where it's open, there's a vacuum, and yeah, you have the force that it's hold everything.
So there's a pin that this goes into. Okay. I was wondering whether you were lining up by eye, but there's actually pins there. That makes perfect sense.
Yeah. So maybe let's run the machine.
Yeah, let's see it work.
Yeah, this machine is so cool. The size is footprint is so small, but it's very reliable. The precision is very high, and we can do everything with this. Yeah, and the way how all this works, because what we see here on the screen is some kind of a preview what the machine will do, but we don't program the machine here. It's done on the computer. So Frank is creating first the model, the 3D model of the front plate, and then he's programming a cam. So it tells where the miller would go and all that stuff. And then we can completely simulate everything, where the cutter is going, what it's doing, and then we bring it to the machine. And when he started the first time, he is adjusting all the parameters. That's the reason why we have also another screen here, where we can adjust all the parameters.
In here, look, it's a live view. It's a new function.
Okay,
that's great.
I didn't saw that before now. Okay.
Oh, that's fantastic.
Next time he's sitting at home with an iPhone, and that's doing home office with like this. Yeah.
These machines. Here you can see the ready front plate, Warren.
Yeah. It's great. So I'm admiring this. It's so much fun. Wow, there's not a sharp edge on it.
Yeah.
It's beautiful. Oh, I love this little detail here, this little bevel here. It's really gorgeous. Excellent work.
Yeah. So how many different parts we are manufacturing here on the machine?
Over 200.
Excellent work, yeah.
Yeah, and there's also another big benefit having this. We're so fast in producing this.
And you can make to order here.
Yeah.
You can, like, we need to do one.
Yeah, not maybe 6 like this,
Yeah.
but
one order of 6 and off you go.
in about 1 week he can do the next batch here.
That's great. Very, very cool.
And here we see the front plates of the music. That's the inside. Yeah, doing on the same way of. Yeah, let's do another one here. Looks always cool.
This is ready.
Wow.
So here's the latest invest last year in 2023. It's the machine to make all these knobs from the Alpha totally complete, and also the knobs from all the other gear. That's what we can do now with this machine. So primarily for this, I mean, you see it's the normal control for all the expressor, X-filter, all that stuff. Normally we got this in, let's say, from Taiwan. From the manufacturer, it's doing this, it's doing the coding and also sandblasting. But when COVID came up, the delivery times were really, really long. And luckily, we switched over a few months before this and find a local supplier. But he could not do it in its final version, so it looked like this. So the knob was not ready. That's because he could do one side, but the other side was not finished. So he came up with some kind of a system to put in 96 of these knobs into the Daton and make these inlays, or these, we named this the DStyle inlay here, you know, and then you can put this on the axis. Here you can see how it's finally, so there's a typical D axis here from the potentiometer, yep. And there's a little bit of, something in between, and then you can put it over here easily. So then the knob is ready. And this machine now can produce the knob that looks like this here. Completely ready, and then it goes to the company that do the sandblasting and the coating, anodizing, yeah. And this is actually now he's running this stuff here on the lathe.
I can show you.
Yeah. So if you're interested in working machines, now you have the next thing.
I love all this machine stuff. I'm
so.
And here you can see.
I didn't realize how fascinating this would be.
Yeah.
Here you can see the basic material. It's a basic material. It's polycarbonate, and we put it in this machine, in this hole. It's okay. I'll close the door. Then I close the chuck. Go to automatic. And start the machine.
Yeah, and as a side note, the manufacturer of this is Citizen, and you know maybe the brand from the watches. Here.
I was wondering if it was the same company.
Yeah. So they built their own machines to produce parts for their watches. There it was. Yeah. So yeah, this has to be removed, and then it's ready.
How long does it take to do each one?
How long is it for what?
About 2 minutes.
About 2 minutes.
Okay.
That's incredible.
But then, with this part, the next step is that we combine this with the aluminium.
Can you reiterate this is for the Alpha?
Yeah, this is for the Alpha. So this is what came out from the machine. Then we combine this together here. But then it's not ready for using in production because this part is also missing here. So normally it's in here like this. This is then the knob, you know. But on the end is a potentiometer, and this now is putting into the potentiometer. And to make this happen, we bring this part again into the milling machine and mill this D part here. And then we can use this for final assembling. Okay, what we have here is also a machine where we put these threads here in the cube chassis. So we got this here from another manufacturer. And this is the chassis for this. But what it's missing is the threads here to put the screws in. And here we're using this machine, and this here is creating the thread. So it's very easy because you can put it down and up very easily, and so you can move this here to make this happen. And so it's also one thing that we do our own here.
This is an incredible shape. There's no, I've never actually looked at it like this in this detail, but there's no visible joins. So this is cast in one, as one thing. There's no joints.
Made for us.
Yeah, that's amazing.
Just when we come up with the idea of the cube, and there were companies doing this, and then I came up with the idea of the shaping. And these nuts here are in industrial style, so you can maybe combine different things or add other stuff. And we put some rubber here that is putting on the table and don't move.
That's awesome. Yeah. So you're future-proofing yourself in case you want to attach things together. Yeah.
What we see here is a drawing, old drawings from the alpha compressor. So this is a drawing of a back panel, and this here, what we see is part like this. But back in the day, we manufactured differently. So these were all single parts, and then we glue this single parts from the back here. But you have to find the right orientation. And so Frank came up with the idea to make it of one piece. So this is a basic material, and then we mill this in one row. So the machine takes about 3 hours of milling this here.
Wow.
But then it is really perfectly sitting together here. And everything's looking like the same, because back in the days, those looked sometimes different in the brightness and everything. And now we have a really good looking piece here.
Wow, that starts off as very heavy. So you mill out a lot out of that.
Yeah.
Is this an alloy? This is like an aluminium. It feels heavier than a piece of aluminium.
It is aluminium.
Oh, wow, it's just very dense.
Yeah.
Oh, I didn't know. I never would have expected aluminium to be this heavy. Where to next?
Yeah, so come over to the next room, and it's completely different to this here. Here we do metal work, and here is where music works. Our Studio B.
Lovely. With some Moses Schneider miking, I see, the drum.
So it's a preparation for the drum recording we do with you and production. But this room is a multi-purpose room, so we use it for studio sessions. We use it also for product photographs, for videos, but also for meetings here. It's acoustics treated here. It looks pretty nice, and so we can travel things here. And yeah, it's really a very enjoyable place.
I love it. It's a beautiful looking studio. What are these speakers before we go on? I don't actually recognize this at all.
Yeah, it's KS Digital, so it's a German manufacturer, and I know the guys. He also has developed PA systems, stuff like this, and I met him, and so yeah, it's a cool three-way system, active, powered, with a digital
phase aligned.
Yeah, phase aligned. Yeah, right.
Wonderful. Yeah. That's a gorgeous looking room. I love it. I like how you keep all your colors very consistent.
Yeah, you have this blue, that yellow, and stuff like this.
Well, this is going to be fun. We're going to come back to this room in another video. You'll see it, and we're actually going to record drums in here using a lot of Moses' techniques and, of course, all of your mic pre's and compressors, etc.
Yeah.
I'm going to be mining your brain to, get sounds I don't normally get.
Yeah, I think this is the combination of me as a developer and having the gear in use with real music. It's not that I'm only the technical guy and sitting with my solar iron. It's also here, okay, I'm part of a musician and know how to use this stuff.
Okay, good. Well, we're going to push you to the limits and find out what we can do.
Okay.
Nice. You know what I liked when I first came in, I noticed, was the seating arrangement all the way around. Who made all this? Who created all this?
Also, Frank did all this. He's crazy. He built all this furniture here.
Oh, so good. In studios, and I've built many studios in my life. I have no idea, maybe 12 studios. And storage is always the last thing you think about. Because you're sitting there and you're designing it, you want it to sound great, you need space to record instruments, you're thinking about building vocal booths and blah, blah, all this different stuff. And at the end of it, you're like, oh, where do we put everything?
Yeah.
And this is just really, really smart.
Come on, a little other surprise here, what we did here. is this one here, where we also have the right placement for the microphones.
Very nice.
Yeah.
And did he mill this?
Yeah, we mill it also ourselves. But unfortunately, I have more microphones now, so I have to do another milling here. So
Oh, there
now
you go. There's space.
that's the reason why I put it here. Yeah.
This is very, very cool.
It's not that, yeah, it's not perfect here, but you see the same idea here to have all this.
And you've got this gorgeous triad orbit stands.
Yeah, they're really good.
They're
It's
really
so
good.
easy to remove a microphone here and do another one. It's super cool.
So where to next?
Come on, follow me. I'd like to show you the electronic production. But first, look at this, what this is.
I love the lighting. It's fantastic. The cubes.
Yeah, we use the cubes to make lights from this, and yeah, it's looking pretty cool.
Very nice indeed.
Come on, and I'd like to show you the other part of the building here, where we do all storaging, electronic manufacturing, everything. So I'd like to start with you here in this room, and that's where we storage everything. The mechanical parts, electronic parts. So on this side here we see everything what we do in the workshop that we saw before. So you see here the complete ready milled and also laser engraved front panels. Yeah.
God, the detail when you get to see them this small, this close. How do you? How's the stenciling on this?
Yeah, this is made with laser. We see it later. We have a laser here, and it was doing the engraving here for the front panel.
Oh, I want to see that. Yeah,
Yeah, that's also awesome.
It's beautiful.
Yeah, and then the thing what the guys did here is when they assembled something, they grabbed something here, and here you find a sign that means, okay, now bring this to the workshop, and then Frank knows, okay, you have to mill the next parts here. So that's kind of a manual system of indicating, okay, now please do the next batch. Yeah, and on the other side, we have the complete electronic stuff. So when we order parts, but they're not ready, we have made a special system here. And come over, because Jacqueline comes now from over here and needs to fill up something, you know? So
Hello there.
she don't know where this part is now. So she scans this. Look, can you see this? Oh. It's flashing. There's light. So now she knows where it is. And it's the same when we order parts and know where to locate this.
So how does it work?
Basically, we have a warehouse system, SAP. This is what you buy. And then a former programmer here created a system that uses SAP. And then he connected SAP with this software, with this lighting system here.
So she turns on this button, she scans it, it then indicates. Do these have a sensor in them?
No, this is a light strip here.
Yeah.
And you can program each LED. So maybe I scan it to make it. So and then these 3 LEDs are blinking here.
No, I love this idea. So what you're able to do is have a handmade product, but you're mechanizing it, I suppose, as much as you possibly can to make sure that you're spending more time actually constructing it rather than half your day just trying to find the components to actually build it.
Wasting time. That is, I think, wasting time is what in many companies can happen. You're looking for something, you want to assemble, then it's not here. And also, what I like to do is one-piece flow. That meant not building a batch of, let's say, 50 devices. And then you have 50 in your storage, but there's no customer for this. And maybe parts that are used in this are also used in another one. And there was some time where the chassis that we got were assembled in another product, and we have to wait for the next batch. And so we disassembled this to build another product that is already needed.
You were saying what sort of a minimum would be like 6 pieces?
It depends on. I mean, that is depending on what is produced. If it is a front plate or a PCB, so the batch size is different. Yeah.
But 6 pieces is a lot more manageable than saying you have to make 50 or 100 at a time
exactly.
just to fulfill 2 orders.
Yeah.
Yeah.
These parts that are used here, let's say these ones here, are THD components. So that meant it is pulled through a hole and then it's soldered. And the line of alpha compressor, music compressor, is completely this way. The next step was also challenging how to convert this into, let's say, smaller footprint and make it more also cheaper maybe. How to have the alpha idea of the complete discrete circuit technology and bring that down. And let's bring this to the next room. So here is the envelope. So this is the master edition, and this is SMD technology. That meant everything is placed from top here and then soldered. And what you see here is a discrete VCA. And this is a discrete op-amp. So instead of having one component doing the op-amp, it's made from different components here. And this is where I'm really good in to create this circuitry. And especially this one here, the VCA is a very critical part. In audio devices, you need VCAs for automation, for noise gates, for compressors. So, and I'm creating my own VCAs, and not only one. I have up to 5 different versions of VCAs that I can use for different purposes. And that we see here. Here, that line, this is the sidechain for the envelope. So there I use traditional op-amps for space saving and stuff like this. So this is the part for the sidechain, and here we have the audio signal path. That is all made discrete. So it's like, I would say, cooking. So if you have a final pizza, put it in your oven and that's done. Or you have all the ingredients yourself and spice it differently. And this is how I make my circuitries here. Yeah, now I'd like to show you how we made these boards here. And I'd like to introduce you, Stefan.
Stefan, how are you?
Hi, nice to meet you, Warren.
Good to see you.
Yeah.
Yeah, and he can explain you the workflow, how to make these boards.
Great. Yeah. Take it away, Stefan.
Okay, so basically we start with the raw PCBs. You see all these golden contacts where the parts are being placed.
Yep.
So this is the first one. Then we have a automatic stencil printer right here. So what this does is applying solder paste for this only to the golden parts that we've seen.
Well, you can smell that. Not through the camera, but you can smell that in real life, yeah.
So I'd like to show you how this works. So we have a system right here. This one closes. We have solder paste right here. And then we have an optical system to really align the stencil with the PCB. And if I press right here, it will apply the stencil.
Very cool.
And this part, or this step, is the first step, but it's the step that is most important. Because if you imagine, if a pad is not applied with solder paste, it won't make electrical contact. So maybe the part isn't soldered right, and then there's a malfunction to this, and the board won't work.
Right. So what is the difference between like solder paste and traditional solder? Do they have the same properties, or is it just a name only?
So you have to imagine that there are small sort of balls of solder in a medium that can transport it.
I understand. No, that's well explained.
Yeah, so that's the solder paste, and normally you would have the solder joint and apply it with your soldering iron. But we have a special method of melting the solder balls in this one that we'll see right after the next step. And so this makes this SMD or SMT production possible. Yeah, otherwise it won't work.
Here's the heart of this production, and you see all the components here. And when having this panel, what we saw over the envelope as example, there are, let's say, 80 different components. So back in the day, we go to an EMS manufacturer, ask them, hey, can you do the board? Yeah, they can, but they have to assemble the machine with up to 80 different components. So I could not order a small amount. I have always to order 200 pieces of that board. And the next thing is all these components. You can ask the EMS to provide all this. They gave me a call, hey, yeah, I would like to do the board, but I don't get this resistor here or this resistor. Then you have to wait another weeks or maybe months. So what we did, we order all these components ourselves, storage here, bring this to the EMS, and he will do the board. So with this system now, we have up to how many components we have that are already on the machine?
Yeah, it's 86 components that are permanent for this one. And only the front from here to here, they change depending on the product that we are producing.
So these components here are the same on every product you make?
They're similarities, and some have, not on all, but they have the most crossovers, I would say.
That makes sense.
So let's see from the inside how it looks like. There's the board, and then there is some kind of a vacuum and going over the components, picking them up and placing over there.
Some parts of this, from the smallest to the biggest. Maybe you can put your finger out, and then I can sort of get this. This is the smallest part we are.
Wow, I do not want to lose that.
Applying to.
It's the size of a flea.
Yeah, and this is the biggest one.
Okay, this is definitely more of a put it in your hand.
This is a connector. And all these parts from the biggest one to the smallest one are on these reels here. And the machine goes to the part, picks it up, checks if there's a part on the needle with a laser. It sort of measures this. Goes to the exact point where it has to place this part. Puts it down and checks again if the part is on the PCB. So even if when there's a power loss right here, the machine remembers exactly the state where the power loss was and continues after the power loss to the exact location.
How does the binding process happen with the paste? Does it have to be heated? How does it work?
Yeah, first of all, the paste is pretty sticky. So if the part is placed on the PCB, the paste holds it.
Okay.
But only for maybe 1 day, then the paste will dry out and the part can roll off.
So it just dries out naturally. You don't have to heat it up.
Yeah. But for really making the connection, really soldering, we have the vapor phase over there.
Okay.
That's like an oven. There are two different types of soldering SMD parts.
Now you know how it works, and the cool thing is now that we can have a way smaller batch now. The time changes is way smaller. So when one product to another, I only have to reassemble this here, and we can do maybe 20, 30, 50 boards, exactly what we need. And this is in my philosophy of these, let's say, not one-piece flow, but we only manufacture the stuff that is needed in the market. So then we have 50 boards, and the components are here are really needed, not missing on other boards. And this is the philosophy. But maybe you want to start this machine?
Yeah, sure.
I'd love to see it in action. This is fascinating. Yeah, this is fascinating.
So what is happening here with the red light is the machine picks up the part. The red light is a camera which looks to the top, and the camera makes a picture, takes a picture of the component. The camera has a reference, how it should be orientated. It measures this in real time, and if it's right, it will place the component on the board. Then we have an automatic tool changer, because not every component, as you've seen on your finger, has the same size. So for a smaller one, we need a small diameter of a nozzle, and for bigger ones, because they are heavier, we need a bigger diameter of a nozzle, and the machine is changing these nozzles, knowing what part comes next.
This is fascinating. Now, how long does it take to populate a PCB board?
So it depends on the board and on the components. For the character, for example, it's between 600 and 700 components, all these small components, and it takes about 18 minutes to assemble one board. But the machine runs all day, not 24/7, but work shift, and all week. Now it's ready and has placed every component.
Now we can show you the next step. This is the soldering process. So this solder paste needed to be heated up to make the connection. And yeah, that's over there. Maybe there's another one in, I think. Yeah. So here was a previous board inside.
We have all these room, and for us it's very fitting because we can put two of these components right in. Yeah, it's a little bit warm.
It's warm, yeah, I was wondering.
Yeah.
So this is all the condensation.
Yeah. So we have a special liquid in this. This is Galden. And Galden has a temperature of 238 degrees where it's getting into vapor, or vaporizing. And this platform here goes down, so it lowers into the steam. And there's a constant temperature of 238 degrees. And this is very good for the components, because normally you would have sort of a reflow oven where you have different temperature zones. And these tones have to be exactly matched to the components. Otherwise, components will melt if they're plastic,
I can imagine,
or not being soldered, which would be the worst case. So with this technology, it lowers. It takes about 15 minutes, not depending on what is in there. It rises up, and then it's ready. And then everything is soldered. You see it's sort of reflecting right here. That means that the solder paste is melted and the electrical contact is there.
So, operation-wise, there's one person in here whose job it is to take this out, put it in here. Obviously, you're doing two at a time. So
yes.
That's an 18-minute process. So every 36 minutes, two are going in here.
Yeah.
But these are done in 15 minutes.
Yeah. So we are currently developing, and Frank is doing this in our construction shop, sort of an inlay for this machine that we can put in more PCBs. So of course the machine will take longer, but it will do it on its own. Yeah? So we can put 4 in these or 2 in these, let the machine do its job, and then put it in right here, and the person who, well, it's me, has time for other work here. So doing marketing, doing programming of the other machines that you're about to see. Yeah, this is sort of an optimal workflow for us.
No, it's great.
Yeah.
That's great. No, I love it. So you can be skilled in one area, and this is just a part of what you do.
Yeah, yeah. And when the PCBs get out of here, we have an inspection system as well. That's located over here. So here we have an optical inspection system. How this one works is we have a drawer right here where we put the PCB in, close it, and do a scan of this. So we can start scanning the PCB. And we have a reference in this where we made sure that everything is perfect and everything is correctly placed from the machine and soldered. So what we can do right now is we have 2 pictures, one reference and the scanned one, and we can really zoom into this.
Is this the scan or the reference? Oh, I see. It's moving between the two.
So what the machine does is it overlays the reference with the scan that we are doing right now, and then it zooms really close to this, so we can do an inspection optical of the parts that they are right. Of course, there are small things like the resistors. You see right here. This is only turned around. It's not a problem because resistors have no orientation, but you have to know this. Or here with the bigger ones with the mouths, this is no mistake, but this is only an orientation thing because one reel has the resistors in one direction and the other reel has the resistor in the other direction. So if one section is ready, we can just press enter and do the next section, and section by section we can inspect if the PCB is right, and then it goes to the next step, which would be storage, or directly to the THT production to put some potentiometers on this or connectors.
So cool. I love this because I think there's always that worry in any kind of mechanization that you just kind of trust it and move on.
Yeah.
And so this again, I think this is the 3rd time I've said this phrase, level of detail is super important.
Yeah.
Yeah.
Next, we are going to the THT assembly to really show what parts are missing.
What does THT stand for?
It's through-hole technology. So everything that is put through the board with the little legs, that is the next room.
Okay.
So come, follow me.
Yeah, here's the next room. And yeah, come over here to this place here. Welcome
Hi
to
there.
Anke. She's doing the stuff here. So what she's assembling now is the alpha compressor. So we see the board here. And this is now different than the boards that we saw before now, because these are the THD components completely. So resistors, LEDs, and she's assembling this. And we use this machine here. See, there is a light now.
Wow.
Then she knows to put the component in there, including the orientation. So this LEDs has plus and minus, or anode and cathode. So even this is indicated here that it's done properly. Because below this, where these LEDs are, there coming other components. So it can move, and that you don't have to search for the components. It will, if we do the next step, then it comes up here. So you can see there are all the other components, and then moving here and putting it to the right place.
There's still certain things that human beings have to do.
Yeah, absolutely.
So my next question, and the obvious one, is like, how are these then soldered?
Yeah, I mean, let's do another step in between. So the place where we assemble the envelope. You can see these are the larger components, like potentiometers. So let's look, I put it out again, so you see it here, and then it's placed here. And then we have a holding system, so that the potentiometers are really aligned here perfectly in 90 degree, that everything is fine. So, and then this system here, this frame, is also done by ourselves. And so here I made all the expressors, X-filter, characters, envelope, all that stuff. Yeah.
At what point do the PCBs get put into the frame? Where's that happening?
Here. I mean, when she started to assemble this, she gets the frame, put it in.
I see.
And then in the frame, it's assembled.
And then that frame is passed over here, and okay, yeah.
This is the way how when it's completely assembled before soldering. And here below, there are switches and LEDs, and these LEDs are at a certain height. Yeah, and this is our solder machine, and this is a selective solder system. So maybe if you look here, in the middle, there's hot solder. So it's like a...
that's the solder I recognize.
Yeah, you know, now it's a different way.
None of that paste.
Yeah. And now you put the frames inside here.
Yep.
The first step is applying flux with the microsystem. You maybe are not able to see this with your eyes because it's a micro drip technology that only applies the flux to the points that are being soldered.
The cool thing is that the laser can do the assembling, and in the meantime, the machine is doing the soldering process. Nobody has to wait here. So when the next batch is ready, it's some kind of circle.
How long does this whole process take?
For the envelope, it takes about 12 minutes. And then 2 boards are ready for the next step for testing.
So what's interesting, so obviously, you know, you're a very niche market. So that nobody's designing millions of dollars worth of machines specifically for you. So what would this machine be more commonly used in?
More in automotive and in this area where the connections must be controlled and really to be sure that the connection is there. And normally you would solder this by another type of machine. So it goes through in some kind of, it will heat it up, and then you have a wide solder wave, and it's way faster than this. Problem is you need more people to get this machine running. So somebody putting that in and out and stuff like this. In the past we got this kind of machine, but it was too much people working here, and now the machine is working automatic for themselves. So the Elysia can do assembling, put it here, put the other one out, and some kind of a circle. Nobody has to wait here for something.
What was your process when you're researching this stuff? When you've designed this equipment, you send stuff out, you're trying to figure out how you can do lower batches more often. Where does your brain go? I mean, do you just start calling the manufacturers and saying, you know, casually asking, hey, where did you buy your machine? I'm intrigued. How do you know what I mean? This is a lot of research to figure this stuff out. How did you do it?
I was on trade shows where all these machines were placed. I got in contact to some guys who helped me what would be the best machines for our needs here, and I got a real plan.
I mean, basically, have you become friends with car manufacturers and stuff like that?
Not really other manufacturers, but I went into, and there's a German company, Rohde and Schwarz. They make measurement equipment, oscilloscope, and I saw their plan. It was amazing, and so I got some ideas from them.
That's incredible.
So now it's soldering here.
So basically, you design the equipment. You manufacture it, you have to figure out how to... There's a lot of designing of the designing, if that makes sense.
We design the stuff that we can produce it here as easy as possible.
Yeah. A lot of level of research and R&D gone into all of this.
Absolutely.
Yeah.
And what's also here in that room is our laser engraver that's here.
Ah, yes, the last part.
So you saw the front panels, how they're milled, and normally they look like this here without any printing. And with the philosophy to this one-piece fill lean production, normally this is a typical silk screen what we would do. So you send this stuff over to another company and they put this silk screen on this. But here's the same problem you have to do with batches. They do it not for one piece. They have to do it, let's say, for 50 or 100. So with the laser, we can do it from series 1 or maybe a batch if you want. And that's what we can do here. And this is the surface here, the blue, it's anodized, blue anodized material. And the laser, let's say, shoot that out. And so then...
It's etching.
Yeah, and then you see below the blue color, the white one. So it's not that the color is
So you see the aluminium underneath
exactly.
the anodized top coat.
Then we made this inlays here, that the position is always the same. So basically you have to put that inlay in, run the program, and that's it. And so we have constantly the same printing on all the front panels. Here is it's an interesting thing because this is aluminum plate and it looks black. And this is by, at a certain point of temperature, it gets some kind of black color here. If you do it too much, then you have the same effect like here. But at a certain point, that you can do some kind of black printing here on this aluminum.
So this is the same principle. This is etched.
No, this is not etched.
Starts to darken it before it actually etches it.
Exactly.
Heats it up and changes the color. That's
exactly
fantastic. Did you already know that, or was it accidentally you found that out?
When we do the research for the machine, there's one thing that this machine offers that it can do, and then we can make so for the back.
It's basically burning it. It's burning it.
Yeah. So it's forever. You could not scratch this. It's really cool. And then even here with the cubes. Primarily, we did this here with our milling machine, but it took too much time. And it's also laser. So multiple times you go with the laser, and then you have a certain amount of I think, a tenth of a millimeter depth of engraving. And then finally, this was the hardest thing. This is the alpha compressor. Before this, we have a printing, but the printing was never that good because the surface is very structural here, and you feel it. So, but now with the laser, the printing is super sharp and precise.
I mean, honestly, I love the level of care that you put into everything.
Thanks.
Yeah.
But maybe let's do the run in the machine, so then you know how it looks like when we engrave these front panels here.
It's magic. That is insane.
And here's the same. Nobody has to wait for something. The machine can do it automatically themselves, and then the door gets open, and then the ladies can do the next batch in. What we can do here with the mechanical part, with this part, we can do prototyping. So what we have here is a front panel of the expector. So this year at NAMM, we placed a prototype of the expector, but it was only a housing. There was no electronic involved. So we create that, we built the front panel, we put the printing here, we make the back panel, put some connectors, but nothing was in. But we can, having a housing looks like the real thing, like a final product. This is a normal cube backplate for our stuff, and here is now the special backplate for the expector with more connections here. And we can do it even if we need 1 plate or 2 or 10, we can do it here. This was the laser engraving, but the panels need to be tested. So follow me, there's the next room here. Yeah, this is Ingo.
Hey.
He's doing the measurements here.
How the devil are you? You good?
Yes, everything good.
Good, yeah, good. Is that good?
Yeah, in this room here, we do testing all the boards. So what we have here is the Sculpture 500, our preamp. And yeah, this is tested here with the audio precision. But maybe a little side note here about the preamp. I think this is also maybe interesting for your viewers. There are 2 special things here with the Sculpture. It's our preamp. we do our own phantom power on that board. But the reason is not because we can do it better than others. The reason is more, part of the input amplifier has a higher voltage, so it's about 56 volts, and the idea is that we have a DC connection between the input of the mic pre and the microphone, because normally there is some transformer involved or decoupling capacitors to decouple the phantom power, but these capacitors always have an influence to the sound. So this for the purest connectivity from the input to the preamp, and that's really, and this is also why this sounds so open and so clear, this sculpture. And another thing is there is no padding involved, so the minimum gain is about 2 dB. So many preamps has, let's say, minimum gain is 20 dB or 25, but very often it's too much if you're miking up a drum kit, and then you do a pad, so the input level is reduced minus 30, then you go up to 45 to have 15 dB of gain, and then you have a not so good signal-to-noise ratio. And with here, we can have all levels and all gainings without any interference in the input section here. I think there's a technical detail, what I never found at other preamps.
Give us a little bit of a talk through on what you do to test it.
Oh, we use the EXEX software.
Okay.
Oh, the precision measurement system here. Yeah,
System
that's
and the software.
Yeah.
And this is a sequencer. It
Right.
starts and goes to the bottom.
I've always wondered, as a layperson, as somebody who doesn't really know that much about electronics, with resistors and capacitors, there always seems to be a large tolerance of value. How do you go about selecting?
With the resistors are often 1% or maybe at certain parts less.
Okay.
Potentiometers have sometimes up to 20%.
Really? That's massive.
Yeah.
It's normal.
Yeah, it's normal.
That's normal.
Yeah.
It's normal,
Yeah.
yes.
Wow. So how do you go about testing them? They're tested before you even put them in, presumably.
Yeah, it depends on the device. So alpha compressor music and compressor,
Yeah.
we do matching of the potentiometer. Have the potentiometer where you have matched them in the, maybe you can show this. So here we give them numbers,
Yeah.
and then we run it into some kind of a testing device. And then, let's say, 100 potentiometers are scanned in with their values. Then a software is looking what kind of number is matching best with another. And then it's left and right in any unit.
And what tolerances are you?
We can go down up to 2%.
I see.
Yeah.
And most of them are bad.
Most of them are bad?
Yes,
Really?
yes.
Yeah. So how you have to buy a lot and then throw out how
yes,
many?
Yes.
I don't know how many. I mean, from the other ports, sometimes it's a half that we cannot use.
Yeah.
Half of the potentiometers. Yeah.
And that's just because the tolerances are too much?
Yeah. Yeah. But there's no, I mean, if you have a stereo device and you want to have close parameters, it's not possible otherwise. Yeah, but let's see here the measurement unit, because we measure so many facts here. So the power supply, the noise, the output level, frequency response, everything. And here there are test needles. We also measure in between stuff. So this is connected on the bottom, so I can show you. It looks pretty cool. So I remove this, and I can put this out, and then on the back, you see how it works.
Ah, I see.
So here are all the connections, and this board is also self-made. So with each device, we create a new one of these test PCBs, and then Ingo programmed everything, and then we can change this. So if you want to check another device, so this is like Espresso Neo, and even this is also self-made, self-milled, and the same way. And now we put it in, and then you can measure the Espresso Neo.
So now we can test the Espresso Neo.
That's really, really cool.
But maybe I'd like to show how it looks like when we have a sequence running, testing the sculpture. Because
That'd be amazing, yeah.
It's highly automated.
Very thorough.
Yeah. So I think these were in. And then Ingo can run the test sequence.
So we start the sequence. Then I start a prompt. What I must do. I start and let's run.
So it's checking the power supplies. If something is, if maybe a short circuit, it will stop. And now it runs through several measurements.
So now I must check something.
Yeah. So all the lights are on now?
All the lights on, yes, it's okay. Next step, the encoder test. It's okay.
So each button needs to be pressed and checked if it is running. Then the jack, because there is a switch into to check out if there's a jack in or out. That's also checked.
So the next PCB.
So all the other switches from the second one is tested. So it's 100% tested, all the boards with all parameters. I don't know how many steps they go into, but there's a lot, really a lot.
100
100?
measurements, yes.
Because of the microcontrol internally, we can change the gain via the software here and do several measurements and different gain settings. And so it runs nearly automatically now.
What's your failure rate?
Very low. I mean, here when we manufacture, sometimes we have issues, obviously, but we find that out. And here we have the possibility to, resolder something, change a component. And we have a camera here where you can see the small components on the camera. More
That's
easy
crazy.
for
How
soldering.
three-dimensional that is, yeah. Oh yeah, huge finger.
Yeah.
This is to suck up the solder.
Yeah, if you're soldering, that the
So you're
dust
not
goes
breathing
away.
it in, yeah.
Over here, we have some kind of a stock. So it's not packaged, because there's a typical 500 module. And what you can see is that we use these panels here also for the 19-inch version, like here. I mean, it's now an X filter, but basically it's the same idea. So the inside of the 19-inch 1U devices have the same PCBs. People ask sometimes, oh, is there a difference in audio and everything? No, it's the same PCB, and therefore you have it designed in a way that you can easily use it in the 500 or in the 19-inch version.
It's very smart.
Yeah. That we can easily so fast rebuild this that we don't need a huge amount of stock here.
Built to order.
Yeah, built to order. Yeah. And then we came up with the idea of the cube, which is basically a housing for this module here, and that you can offer something that's more portable, because we got some requests from people when they're starting into 500 format, they should first buy this big chassis and then have one module in. And that was the idea, to start with the cube, to have it ready. And so it's everything in there. We have the module, but also on the back side you have a connectivity. They have the power plug here, and that's it. And also it's an option for it's portable. You can stack this. And then when it is assembled, like this here, it is tested again. And in this case also with audio, so with headphones running audio and music through.
Where's it being assembled? Here on this bench?
No, in the next room.
Oh, next room. Okay, yeah. I was thinking, this is one guy.
Basically, the boards came from the other rooms, but here they came back and tested again.
I see. Amazing.
Also with audio precision, with some sequences, and even in this case, the power supply is measured if the voltage is okay and low noise. So here we are in the assembling room. Yeah, this is my father. I'd like to introduce him.
And he's going to be building them for you?
Yeah, Alfred, yeah. He's my father and dad. And he also supported us when I started the company.
Right.
So in the basement of his house, we started the company, and the room was pretty much like this here. So one room where everything happening, and when we grew, the whole house was packed full of storage and everything, all the corners, yeah. And he was also the first member of the team. Help us, yeah.
There you go.
Yeah, what we see here is the assembling table. So from this philosophy of, let's say, one-piece flow, that we don't have to do a big bunch, we can do only once if you want. So over here we have a presentation which indicates you what to do. What is the next step, what tools you need, and then you press a button. And then it shows up how it should be fit in here and what the next steps are, and what to put into this thing here. Yeah, so the next are the threads here put on top of this, and so it's in a fixed sequence that we assemble everything here. And even if it is a 500 or 19-inch version, we can do it here, and everything's organized, and everybody can do it.
You made it idiot-proof. So
Yeah.
even I could do it.
Yeah,
Even me.
Yeah. I mean, then sometimes people are on holidays or maybe left the company, and so everybody can do this in the same quality, in the same sequence, and this is important here. Then over here, my wife is assembling the alpha compressor. So if you take a look from the top here, how well this is designed here and manufactured, and even these boards are somehow symmetrical, and this is a power supply here. So yeah, that's really an art. And now you can see all the singles part that you saw in the workshop in the unit.
Incredible.
Yeah.
If this was all like point-to-point wiring, it would be enormous.
Yeah.
Yeah.
And then you see how these knobs are working here.
Yeah, the attention to detail. I know I've said this like 8 times now. It's ridiculous. Yeah. Incredible.
Yeah, so this really, if you buy an alpha compressor, really something in there.
How much do these retail for?
I think it's 12K in the US, something like this.
It's amazing. What is this?
This is a system to solder this directly into the PCB here.
Okay.
So it's a little PCB because these cables are very, I don't know, it breaks too fast.
Delicate, yeah.
Yeah. So it's another way of connecting it here.
I see.
Yeah.
It's beautiful.
So all the boards are tested themselves, calibrated, and then they're finally assembled to this kind of block. And then this is again tested, and then it's built here into the unit.
Any sort of estimation how long it takes to assemble this from start to finish?
We never calculated this because it's so many different steps in between, and I have to calculate that down. In one day you can assemble it completely, but you have to manufacture all these parts and all that. So I don't know. But fortunately, in the past, the delivery time easily could have, let's say, 3 months from build to sell this. But now we are way faster because of that manufacturing process.
What I love about it, from the front to the back, it all sort of makes sense. It doesn't, in English we have this phrase, it says mutton dressed as lamb, where it's like something looks really good from the outside, then you open it up and it's a complete disaster, you know what I mean? Yeah, this is not like that. This beautiful front, everything inside, it's front to back, internally, everything is just so well laid out and designed.
So here's the packaging. So this is Mikey. So he's also responsible for sales and all the dealers and ordering process and stuff like this. And even here we have the same philosophy that you can package one product or maybe multiple. And therefore, when we get an order, let's say a big dealer is ordering something, then we know, okay, this, let's say 5 devices, and then these are packaged and immediately put in a larger box to send out via UPS, and that's what we're doing here. And also everything is in the right position, the manuals, the cables, everything is what you get immediately.
Absolutely love it. I love all of the detail here. It's
Thanks.
It's ridiculous. Like I said, it's exactly what we would hope it would be. When I was asked earlier, like, is this what you expected? I was like, yes and no, because I think it's even exceeded our expectations.
Yeah. Nice.
Yeah.
Okay, the next thing is development.
Let's go and figure out where you design these incredibly clever boxes of yours. Although I still want one of these.
Yeah.
I love it. Emergency compressor.
Yeah, right. Here's my office. And there's a little test bench that I have here, a little bit of measurement equipment. So this is here an example how I did prototyping in the past. So you see all the components, but with this system I can easily remove them and put them out in again. So on the other side, you have all the connections. But with this prototype I can testing, measuring, and also audible tests. So this was the way I've done it in the past. So now I will using different techniques. So let's see here. This is here a software, this screen here, it's a simulation tool. So it looks like a schematic of how I made it. And this is now here a little shelving EQ. And now I can simulate here the frequency response. So I press here Let's check this out. So now we have
You're doing it
here
the
a
other way
typical
around.
frequency response of a shelving EQ in different positions. Here's my 0 line, and here's a low shelf, high shelf. So I exactly know what it came out, or especially with my discrete designs, I can measure all the current. So it's a proof that everything works fine. And then I transfer this into my real board design. So this is my software that I use to create the board. So this is how the schematic looks like. And this is now the real board, where all the components are on. And with another view, it might be a little more obvious. It's in 3D view, and you see how it looks like. Yeah, and then this is now the super nice thing with all the machines that we have here. It takes about, let's say, 3 to 4 days to have a prototype of that panel here, of that board. And then we get it, and then Stefan prepares everything with the SMD machine, put it on, and then half a day later, I got a running prototype here. So I do my measurements here, and so we can do the next steps. And this is so fast, it's so nice, and then I can also measure if the current is like I have simulated everything. And yeah, this is the next step for the future for us. So this combination of simulating, development, manufacturing, we can do way more complex devices like the Genix. So let's go over and see this, because
this is exciting.
This is the future. And maybe if the people don't have seen this, but this is really, really cool thing. This is a recallable channel strip. The name is Genix Studio. And yeah, what we see here is a very unique design, and all the circuitries internally will be completely is a new development from scratch. And so what we have done here is very analog feeling control. So if you touch this and move this, it's very sensitive. It's not an encoder, it's an endless potentiometer.
Wow.
So with a natural angle that you turn, it feels like real. And it's not like an encoder where if you do multiple turns to get from one end to another. Mm-hmm. And here, the whole design was created by Frank, and he did all the design of the buttons, of everything. And I think this is where we come up with this kind of recallable equipment, but very analog feeling here. Mm. And also this EQ will have a dynamic EQ inside. It's also very special. Yeah, and this is the first of this kind of a series, and this will come up hopefully in January of 2025. And then we have other ideas for upcoming products in this range.
So we were talking off camera actually about this, about all of the difficulties of making potentiometers recallable.
Yeah.
You know, some companies use servo motors on a traditional high-quality potentiometer, but that means you wouldn't be able to make it compact, or you'd be limited to maybe 2 or 3 things. Here you've got, what, how many is that 20?
50 controls here.
50?
15,
yeah,
But
sorry.
the thing is here, you can use the controls multiple. So let's say here is now my gain for my low gain of the EQ. If I push it longer, then it became my Q control.
Oh, well.
Like this, or maybe with one push, it's my dynamic section. I can see, okay, this is my dynamic reduction here. So, or here with the monitor section, this is normally the monitor output, but when I assign the artist, now these 3 became the monitor section for the artist. So we have some kind of multiple front play that can be changed in different areas, and this is not possible with a motor potentiometer.
Right, exactly.
Yeah. Even if it looks complicated or not, but you have a deeper level of what parameters where we have an access to.
No, it's ridiculous. Yeah. I mean, to have 3 different jobs that potentiometer is performing, and also make it completely recallable. Yeah, which is why you've not rushed into it. You're getting it right.
Yeah. So that was our vision of recallable equipment, so that you have this analog feeling and can also do some blind adjustments. Like, you know, okay, I do like this, and that's the right angle on the potentiometer.
Are you going to be able to eventually make this into something that's a 500 series? Because of the amount of...
We have other ideas because
Yeah.
this is now the, let's say, top line of how we can do it. And there may be other ideas how to reduce this a little bit and make it also in the price range a little bit lower. But it's a starting point because we have to develop the complete analog signal path completely from scratch new. So we see here the result of the manufacturing process, of the development process, of everything, because we could not go to another company that mills this front plate and all the other stuff, or it will cost lots of money. So we can do everything here.
So tell me the story about this photo here.
Yeah, this was the time when the ideas to found Elysia was, there was a pub in this town here, and Dominic Klaassen, and we were in the band playing, and then we go into this pub, and then there come up the ideas for Elysia, and then at a certain point we have to create some notes, and you see here some kind of a logo thing going on. Yeah, and so that was a foundation of this, of the first ideas for the company. Yeah.
Who had the bright idea of taking the photo?
I think it was Dominic, yeah.
Yeah, good.
Yeah.
It's captured for all of posterity.
Yeah, absolutely. Yeah. So we put all the ideas on this.
Wonderful thing to have.
Yeah. Here's a price tag, you see. 15,000 euro for the Alpha, and then, okay, we get down to 10,000.
You've got to make it more affordable.
Yeah. Like this.
So I think it's fitting that we end where it began. Thanks ever so much for taking us around the factory. Like I've said multiple times on camera, the attention to detail here is absolutely superb. It's exactly what I want. When I look at the front panel and I go all the way through all of the internal workings of your equipment to the back, I can just see how much love and attention you put into it. So thanks ever so much for showing us around.
Thanks very much, Warren.
Thank you.
Coming.
Of course, there's going to be a whole bunch of links and stuff down below. Any questions, please leave them down below and I'll try and force Ruben to answer them.
Okay.
Got it on camera, he said okay.
Okay.
Thanks everyone. So long, farewell, auf Wiedersehen, au revoir, adios. Tschüss.